Space, the final frontier. This is the Observer's Notebook, the official podcast of the Association of Lunar and Planetary Observers. Its mission to explore the solar system, to seek out new observations and data, to boldly go where no podcast has gone before. And now the host of the Observer's Notebook, Tim Robertson.
Hello and welcome to episode 223 of the Observer's Notebook, the official podcast of the Association of Lunar and Planetary Observers. I'm Tim Robertson, your host, and I want to thank you for joining us. And a special welcome goes out to all of our new viewers and listeners. Thanks for finding us. I hope you enjoy the show and become a part of our growing community. This podcast is made possible by support from you, our listeners. If you'd like to help the Observer's Notebook, you can join us on Patreon. For as little as $1 a month, you can support the podcast. For at $5, you receive early access to the podcast before it goes public. For $10, you receive a copy of the Novice Observer's Handbook. And for $35 a month, you receive 1 year's membership to the ALPO and producer credits on the podcast. You can find out the details at www.patreon.com/Observer's Notebook. And to learn more about the ALPO, visit our website at www.alpo-astronomy.org. There you can join the organization, and membership starts at only $22 a year. And now let's jump right into episode 223 of the Observer's Notebook podcast. Enjoy. All right, I'd like to welcome everybody back to this edition of the Observer's Notebook podcast. And you can tell by who's on the screen with me that we're going to be talking meteor showers. Welcome, Bob Lunsford. How are you?
Thank you very much. Thank you very much. I don't think I've ever mentioned it, but I think folks would like a little background on me. I've been the Meteor Section Coordinator for ALPO since 1989. Um, I was voted as a permanent coordinator at the JPL for the Neptune encounter, if you remember that.
Oh, yeah.
So yeah, 36 years ago. So it's been a long time, but it's a lot of fun. Met a lot of people,
Mm-hmm.
and my goals are still to get people interested in astronomy through watching meteors. And I think it's a great starting point because it's inexpensive. You don't need a lot of equipment, and you can basically lay out in your backyard and look up at the sky. And it's a great way to learn the constellations and to get to know the sky really.
Yeah.
And you should really know the sky before you jump to binoculars and telescopes. So, and observing meteors will let you do that.
That's true.
Now, it's been kind of a challenge, to be honest. I've never had more than a dozen or so active observers at once, and that was during the Leonid storms back around the year 2000. The main problem is you're asking people to go outside and like watching fireworks, but you want them to categorize them. We mean, could you tell me how many fireworks you saw at this display? Could you tell me the exact minute when it happened? Could you tell me the colors, the duration, and the shape? They're gonna look at you like you're crazy. Well, I think it's the same thing with meteors. You know, you can get them all the information, but to be honest, they're going to drive out to a dark site and sit on their warm hood and just enjoy the show like they do fireworks.
Yeah,
So,
and you get the same response as fireworks from meteor showers. I mean, you always say, "Oh wow," when you see a nice one.
yeah,
It's always, and the same thrill is always there. So
very
yeah.
true, very true. And you can pretty much expect, you know, when the fireworks are going to show up, every
Hmm.
10 seconds or so. But meteors are have that mind of their own. They tend to appear in clumps. You can go out there and set up, watch for 10 minutes and not see anything.
Hmm.
And then the next minute you'll see, three, four, or five meteors all shooting. And it's like that all the time.
Yeah.
When we say that meteors are going to produce a rate of 60 an hour, well, they're not going to appear one per minute, believe me. You're going to go 10 minutes without seeing a thing, and then you'll see five in 1 minute.
Right.
So, it can be maddening at time. It's like watching grass grow. But you know what? It's worth it when you spot a fireball or
Hmm.
you get a cluster of meteors that show up, and then the oohs and ahs come out, and you say, "Hey, it was worth it freezing my you know what off."
That's very true. I have experienced it many times. I'll go watch a meteor shower, and I'm surprised by how many I see.
Yeah,
So
yeah,
it's a easy study to do. It really is. Just takes
very good.
patience, and you don't need to look through a telescope or anything. You just sit back in
No,
your chair, drink your hot coffee
that's
or
very
hot
true.
chocolate.
And you know what? The Geminids are a good starting point is they're visible all night long.
Hmm.
You don't have to wait till 2 in the morning to see them. Uh, in December, the constellation of Gemini rises as the sun sets, so it'll be low in the east. You can observe at that time. You won't see much activity because the horizon's blocking off a good portion of the Geminid meteors because they're shooting in all directions. But as the night progresses, Gemini and the radiant, which is near the bright star Castor, rises higher in the east, and you start seeing the meteors shooting in every direction, straight up, straight down,
Hmm.
and across. And about 10 o'clock local time is the start of the prime time. If you start then, you will see a good majority of the ones that are visible. And as the night progresses, the Geminid radiant will be located overhead right around 2 o'clock in the morning. So that's the absolute best time
Yeah.
to see them.
What day is that?
Now, the Geminis are actually visible anywhere from December 1st through about the 20th.
Okay.
But the Earth passes through the thickest part of the swarm of material on the night of December 13th, 14th.
Okay.
So that'll be the night to circle if you're really serious about this shower. And that just happens to be a Saturday night, Sunday morning this year. So you know what? It couldn't get any better.
Don't have to get up
And
early for work.
yeah, for sure. And a bonus, last year we had a full moon for the Geminids,
Hmm.
which means you're only going to see about 10% of the actual meteors because most of them are faint. But this year we're a lot luckier. The moon will rise at about 2 o'clock, but it'll only be a 25% illuminated crescent. So
Good.
it won't be a problem unless you're looking toward the east right at it. And still 25% crescent moon will will ruin your night vision if you're looking right at it.
Now, is that what
So
makes the Geminids one of the better annual meteor showers? Because as opposed to the Perseids and the Leonids, that period of time you can see them is more extended.
actually the Perseids can be visible all night long too,
Okay.
but the night's a lot shorter.
Ah,
And
okay.
and yeah, it's basically the night is a lot shorter, and the Perseid radiant is situated in the northern sky, so it doesn't get as high, nor does it reach the meridian. By
Okay.
the time it reaches meridian, it's already getting light because of the short night. So the Geminids are visible all night long, best at 2 o'clock, and prior to moonrise, you can look in any direction
Hmm.
because that's when you'll see them in any direction. If you're looking toward the west at that time with Gemini at your back, it may be a little difficult to separate Geminids from random meteors because you really don't have a good view of the constellations. So what I like to do is I start out in the east, look toward the radiant so I can tell. tell the ones coming out of the radiant.
Hmm.
And there's other minor showers at that time too. There's one in Coma Berenices, there's one in Monoceros, and there's another one in what was that other one? The anti-Helian radiant, which is over in Orion.
Okay.
So those are a lot less. 90% of the meteors you'll see in December are going to be Geminids, at least while they're active.
Okay.
So you can count on them being Geminids, but still, if you're facing away the radiant, you won't be 100% sure.
Okay.
Now, after the moon rises, I would suggest switching your view over to the west with the moon at your back. Uh, the radiant will be setting in the west, so it'll be coming right toward the center of your field of view, and that'll allow you to see the most meteors if you're going to be up at that hour. So I imagine most folks are going to be taking the evening shift and watching them, from maybe 10 to midnight. And if that's the case, look toward the east. You'll have no moonlight problems. You'll see them
Okay.
shoot in all directions. And if you're up after the moon rises, yeah, shift toward the west, and you'll see the radiant pass through your field of view there as the night progresses, and you'll make the most out of it.
Okay. Sounds good.
Now, let's see. Oh, I imagine there's someone in Australia watching. Well, can I see him? Sure, you can see him. The constellation of Gemini rises in your northern sky and only gets about 20 degrees high. So you'll see a lot less activity. It's like watching the Geminids here from like 8 o'clock at night. So it doesn't get very high. You'll see meteors shooting straight up, but only probably 25% of the activity that's visible in the northern hemisphere.
Okay.
If you go any further south, it's going to be daylight 24 hours that time of year. So folks in Antarctica are out of luck. So
Okay.
they are, but they're visible from a good swath of the earth. So nothing to worry about there.
Okay. So nothing for the penguins to see.
Nah, they're going to be disappointed.
Okay.
So Um, now, what are our Geminid meteors? Well, they're actual particles from an asteroid named Phaethon. This the parent comet of the Geminids wasn't even known until 1983 when the infrared satellite called IRIS discovered this faint asteroid in its field of view.
Hmm.
And it turns out that follows the orbit of the Geminids perfectly. And so we've got a good orbit since then. And this particular asteroid, it has an orbit of let's see, 1.4 years, so a little bit longer than a year. So, and it
Hmm.
passes very close to the sun. Now, comets, every time they reach perihelion, a lot of their material is blown off by the solar wind. Well, not, asteroids are rocky.
Right.
So you wouldn't think solar wind could handle that. How could it blow rocks and stones away? Well, it turns out Phaethon passes very close to the sun. And every time it is at perihelion, the material gets heated,
Uh,
and then the
it, va-
particles are small enough to blow away.
it
And
vaporizes some of the rock.
correct.
Ah,
And
okay.
in fact, the Parker or solar space satellite
Hmm.
detected a tail of particles actually coming off of Phaethon.
Oh, wow.
So it actually looks like a comet because it has dust blowing off it, but they're certainly not made of ice like the
Okay.
regular comet particles are.
Interesting. Now,
Yes.
how many meteor showers are related to asteroids?
There's only two that we know of right
Okay.
now. It's the Geminids and the Quadrantids of January.
Okay. Interesting.
And once again, that was a recent discovery. And I think I can't remember the exact name of it, but it's like 2015 EH1 or something. It doesn't have a proper name like the Phaethon does.
Okay.
So, but it's quite rare. And once again, that particular asteroid probably passes close to the sun, and dust is vaporized off it. Now, you would think if it's actually an asteroid, why can't it produce fi meteorites on the ground since they're more dense and they're hard. But the answer is that they're so tiny,
Hmm.
and they're entering the atmosphere at 35 kilometers a second. So still, even though that's only in the mid-range of meteor velocities, that's still awful fast.
Yeah.
So a great majority of these tiny dust-like particles that make up the Geminids burn up while still many miles up in
Okay.
the atmosphere.
Okay.
So, but it's interesting stuff, I tell you. Now, uh, other studies of phaethon have shown that is indeed made up of material that's very similar to meteorites found on the ground. They have a high concentration of iron and
Hmm.
manganese, and meteorites also normally have a high concentration of sodium, but it turns out that the heat really dissolves or the sodium when it gets close to the sun. So that's not so much representative in the spectrum of a Geminid meteor.
Okay.
So we have people out there with spectrographs in front of their cameras that try to obtain um, spectrums of these bright meteors,
Hmm.
and that's how we can tell what they're made of.
Okay. That's an interesting study.
And also, but using high-speed video cameras, we can tell the beginning height of the Geminid meteors and where they also totally ablate into nothingness. And it turns out that these Geminid meteors are like your normal uh, rocky meteors and they do penetrate further down to the atmosphere, but still they're at least 25 miles high when they totally vaporize.
Okay.
Whereas most of them appear uh, at an altitude of 50 and they're gone by 35 or 40 miles up.
Wow.
So
Just a flash, basically.
there's basically a flash of a little itty bitty particles, though.
Hmm. Okay.
So it's pretty interesting stuff, I tell you. Um,
You have any
oh,
charts or anything you want to share too? Or
Yeah, and I also want to mention that
oh,
Japan is launching a satellite called Destiny
okay.
that's gonna go to Phaethon and study it and give us a lot more insight
Oh my.
into exactly what it is. You know, some folks call it a rock comet, and some say it's strictly an asteroid. So, but I think it's probably a combination of the two. It may have been a comet many years ago. It may have actually broken off of a larger object and settled into its orbit and produced a tail early in its life. But nowadays, it's just limited to a invisible dust tail. So, but this satellite, which will reach Phaethon in 2030, will give us a lot of insights into this.
Now, what type
So,
of mission is this? Is this a just a flyby photograph, or is it a sample return where it's going to
no,
travel
I
around?
believe it's a flyby
Okay.
photograph
All right.
and all kinds of instruments to study the material.
Okay.
So, but that's called Destiny, and it stands for something but I can't remember. But
Got it. Uh, 35 years of
it,
NASA. Yeah, acronyms are a thing that
yeah, there you
they
go.
fill
Just
your
go,
brain.
yeah, go to your Wikipedia and
Yeah.
hit Destiny with the with a period after each one, and it'll tell you what it is.
Yeah. Or you
Or you can look at,
get a picture of Destiny's Child too. You never know.
yeah, there you go. There you go. You might be safer just Googling Phaethon.
Yeah.
Okay. Well, let's look at the circumstances
Okay.
for the Geminids here. And let's see here. Let me first show you where the radiant is. This is the sky
Okay.
in mid-northern latitudes at 2 a.m. in the morning. And I have the Geminid radiant here in red, located right next to the bright star Castor. And we're looking due south here.
Okay.
And the Geminid radiant would be very close to the zenith.
Wow.
So if you're looking south, it's almost overhead, and meteors will be shooting in all directions. And if you're looking south, they're probably going to shoot to the north. And if you're looking north, they're going to shoot to the south, especially if you have somebody with you, because they always tend to see more of where you're not looking. So
Okay.
if I have a buddy out with me, I say, hey, look in the same direction because I don't want to feel like I'm missing a whole lot. So, um, I'd also like to show some circumstances of the early evening and
Okay.
early morning hours. So, one moment, please.
Mhm.
And here we go. Let's see. I think. Okay. I'm going to turn this around so that we have constellation Gemini on the eastern horizon. This is what it looks like at 6 o'clock in the evening with Gemini lying right on the horizon.
All right.
So as you can see, only meteors shooting upwards can be visible. Those shooting sideways or down, no chance. But there is one good thing about observing this time of night. Any that you do see shooting upwards will just graze the upper part of the atmosphere. Thus, we call them earth grazers, and they're a lot different than ones that you see when the radiant's overhead.
So what's this set for? About 35 degrees north or
It's set for 40 degrees
40
north.
degrees north? Okay.
Right. So at this time, they just graze the atmosphere. So instead of lasting less than a second like your normal Gemini does, these will last 3 or 4 seconds. And instead of being short, 5 to 10 degrees, these will stretch for 40, 50 degrees,
Wow.
sometimes even half the sky. So at the time it gets dark, you may see a lot fewer meteors, but the ones you do see, if it's dark enough, they're very cool, let me tell you.
And that's because of the attack angle of the meteors toward the Earth.
Exactly, exactly. They cannot penetrate deep at this angle.
Yeah.
So what they're doing is they're just skimming the atmosphere. And
Mm.
I have found that a lot of them shoot sideways. They'll go due west or due I'm sorry, due north or due south
Okay.
out of the radiant. So if you're looking over here toward the Big Dipper, that's a prime spot for Earth grazers, and over here past Orion in Eridanus, another one.
Okay.
So they don't tend to be bright, but they're long and long lasting. So they're very, very interesting.
Good to know.
So as the night progresses, um, let's go ahead and shift this. And I'm going to go back to our southern vantage point here, due south. And you can see the radiant is right here near Castor.
Okay.
And it's swinging higher and higher up the sky. And the meteors are now coming more directly. And here's where it was at 2 o'clock in the morning, directly overhead. So they can be seen in any directions. These meteors will be a lot faster. Very seldom will they last more than a second, and very seldom will they be longer than 10 degrees.
Because right
Most
now
of
the
them,
Earth is going directly into the radiant, right?
that is that is correct.
That's why they're going shorter. Okay.
That's very correct. In fact, the Geminids kind of hit them perpendicular.
Okay.
So, it's that's why they're only medium speed and not a head on like the Perseids are. So, if we go further into the night, it's going to be drifting into the western sky. So here we look in due west,
Hmm.
and we can see Gemini sinking this way. The moon will be at your back. You have nothing to worry about there, and you'll still have a good view. And the meteors will be shooting down toward the western horizon if you're looking west, over toward the North Star, over toward Hydra. And that would just be my, of course, if you have a industrial complex toward your west, you might want to, turn a little bit more toward the north
Right.
because you will see meteors in all parts of the sky.
Okay. Great.
So, yes, sir. Um, let's go ahead and talk a little bit about equipment you need. Being December, you don't want to go outside and stand and watch meteors. You'll start to get cold, your neck will hurt.
Hmm.
You want to be very comfortable. So I would suggest getting a nice lounge chair, and I put a padding underneath it. And if it's really cold, you can actually crawl into a sleeping bag.
There you go.
So do that. And I'm in San Diego and it hardly gets below 50. I'm still the wuss. I'm out there with an electric blanket.
Hey, if it makes it more comfortable for you and you can do it longer, then so it works.
Ah, anyway, yeah, it's kind of hard to do that though when you're out on a remote site. So anyway, no electric blanket there, so you take a lot of coats and blankets and
Yeah.
pillows and keep warm. Maybe even having a thermos of hot chocolate.
There you go.
But I'm going to be heading out for probably 3 days, centered on the night of the 14th, because that activity will be actually the activity is a little better before the maximum than after. The activity curve after the maximum seems to fall off faster.
Oh,
So you're going to see more meteors on the night of the 12th, 13th than you will on the following night, the 14th,
okay.
15th. The only problem is the moon will be won't be rising. It'll be rising at about 1 o'clock then instead of two. So
Okay.
you're going to have a little more interference from moonlight.
Got
And
it.
the same thing happens if you even observe earlier in the calendar month of December.
Okay.
So it's give and take. A little more moonlight, a little more activity. So and less activity afterwards, but less moonlight. So, but and for sure, uh, Friday night, Saturday morning, Saturday night, Sunday morning, those are the prime ones to view from.
Okay.
And another reason I observe from a dark sky site is you will see more meteors because the majority of the meteors are of third, fourth, and fifth magnitudes,
Hmm.
which means you got to be looking right at them to see them. So there will be bright ones, and maybe even a fireball, and but a majority of them are going to be fairly faint. And if you're watching from the city limits in your backyard, you're going to see a lot less. Now, you're going to see quotes saying, "Oh, this shower's worth 100 meters an hour." Well, that's under perfect conditions with the radiant straight up. You might get 100 an hour. But I was 2 years ago, I was out from perfect skies and I caught 60. So I think the main reason for mine not being up to 100 is I'm getting old and can't see as many as I used to.
That is a factor.
Let me tell you though, back in 1989, there was 1 hour I counted 123 Geminids.
Wow.
So,
Wow.
it's not that the Geminis are actually getting weaker. It's I think my eyesight is getting weaker. Didn't need glasses back then, and I could lay on that lounge chair for 6 hours, but pretty much
Now,
limited to 3 or 4 hours these days.
now, what about photographing? a meteor shower? I mean, for this one in particular, I mean, you don't want to point your camera directly at Gemini, obviously. You want to put it to the north or south of it, probably.
That's a good idea because the longer meteors occur further from the radiant. Um, when meteors occur near the radiant, they're shooting directly at you. So they're going to be very short and they won't appear on film very nicely. Actually the best distance from the radiant is 90 degrees. Now
Wow.
that may seem a long way away,
Yeah.
but when the radiant's on the horizon, that's straight up. So that's not bad.
Hmm.
When it's, halfway up in the eastern sky, that's halfway up over in the western
Okay.
sky.
All right.
So yeah, but I have found to get your best meteor shots is to have your camera aimed just above the horizon. And the reason for that is you're looking through a much thicker swath of atmosphere, which will show a lot more meteors.
Oh, I never thought of that.
Yes, sir. So if you see, if you go to the ALPO website for meteors and look at all the fireball pictures in the gallery, you'll notice most of them have the horizon in the view.
Like the
In
one
the
right
view.
behind
Yeah, there you go.
you.
Exactly,
Very cool.
exactly.
Okay, so if someone wants to photograph it though, 10-minute exposures, something like
It
that?
all depends on how dark your sky
Okay.
is. If you're in the suburbs, you probably want to limit it to a minute.
Okay.
Otherwise, your camera will be your film will be overexposed and you'll get star trails.
Okay.
So what I plan to do is set my camera on a very fast rating of ISO 1600 and take 30 seconds exposures.
Okay.
And I've got a machine that automatically does it for me. I don't need to crawl it out of the sleeping bag every 30 seconds and do it like I used to in the old days.
I hear you. I hear you.
So so
Okay.
it can be easy and it can be fun. Uh, Even if you take longer exposures in the star trails, that kind of helps you tell the meteors from the stars
Mm,
because the stars all have an arc and meteors will be straight.
that's true. That's
So,
true.
but
Yeah.
the Geminids are very photogenic. There are a lot of bright ones, and they're very colorful too. Uh, the high high concentration of magnesium will give them a blue color,
Okay.
iron sometimes a yellowish and orange, and I've even seen green Geminids, which says that particular one had a high concentration of nickel.
Oh my.
So yeah,
Okay. Now, what
so
about um, sending observations to you in the meteor section? What are you looking for? Meteor counts? What type of things?
right. What what we look for is folks that will observe for an hour and count the number of Geminids versus non-Geminids. That's a great way to start. Just the counts are important. That tells us the density of the shower that we're currently experiencing during that time. And if we can get people all over the world doing that,
Hmm.
we can get coverage of how, we can get 24-hour coverage, when it's light here and it'll be night on the other side of the world.
Right?
Get folks to do the same thing. We can get a really good activity profile of the Geminids. And that's what we try to do year to year.
Hmm.
And that way it allows us to predict future maximums. Now we got it down to pretty much of a science on the Geminids. Most of the people agree it's going to happen on the 14th or within a certain number of hours. But you know what? The Geminids are strong for a full 24 hours.
Yeah.
So people in Japan are going to see basically the same rates we do here in America and the same thing over in Europe. So
All right.
they'll see a good show if your weather is clear, if the sky is transparent, and you're in a dark spot. So yes.
That's the key.
Now, if you really want to get crazy like me, you can try to estimate the magnitude of each meteor. Now, what that shows us is the particle size. Naturally, larger meteors will produce brighter media. Yeah. So, uh, if we can get a tally of the magnitudes,
Right.
that'll certainly help. Now, you're going to find out that most of them peak for the human eye between magnitude 2 and 3. And that doesn't matter where you're. Well, I should say, if you're really at a dark sky, it could be between 3 and 4. But for most of us, if you count the magnitude, they're going to peak right around 2 and 3.
Okay.
Now, what you really want to hope for are ones in the negatives that that produce colors, and don't expect persistent trains like the Perseids. And the reason for that is they're only half as fast as the Perseids.
Okay.
So they're not going fast enough to produce that little smoky trail that the Perseids are so well known for.
Okay.
Other things that you can tell, and the most important one is your sky quality.
Hmm.
Now, I've got a very simple form on the ALPO site that says, dark, very dark, just for beginners. But if you really want to get exact, you can estimate that your limiting magnitude, which is the faintest star you can see. And what that does is it tells us, your sky conditions and what to expect. So someone that's observing with a limiting magnitude of 5.0, we can expect that he's only going to see 50% of someone observing under a limiting magnitude of 6.5.
Right.
So
Yeah, the term for that is transparency. That's what we use in observing.
yeah, yeah, yeah. And so that's important. And the IMO has published a list of sky charts which uh, are located and easy to read. What they are, normally they're triangles or squares. And what you do is, for instance, the area of Taurus, the two stars in the horn go down to Aldebaran. That forms a nice long triangle. And what folks can do is count the number of stars in there
Mm.
and then refer to a table. And if you saw 8 stars, your limiting magnitude is like 5.75. So, and that's a lot easier than looking up and saying, well, that star right in the middle of the Little Dipper is about the faintest I can
Yeah.
see. And then turn your flashlight on and see, oh, that's magnitude 50. So uh, we're going to have links in my upcoming Geminid article
Okay.
that will help folks submit scientific, useful observations.
Oh, great.
And believe me, we can use all that we can get. Even though the Geminids are well known, the more information, the better.
That's true. It's a good way to get into science and astronomy too.
Amen. I tell you, you start out learning the constellations, and then you can work your way up to binoculars and then a telescope, and pretty soon you'll be discovering supernovas in the distant
There you
galaxy.
go. I like that. I like that.
How
Yeah.
come that hasn't happened to me yet? Uh, anyway, I
Yeah.
think we pretty much covered the Geminids.
Yeah.
I'd like to share with folks that we have another weaker shower if you get rained or snowed out for the complete Geminid display, and it's called the Ursids. And this shower is active between December 17th and Christmas. It peaks on the morning of December 22nd. And let me share a chart of that with you.
Okay.
Well, you know what? I probably forgot to highlight it. So that's okay. Anyway, this is the bowl of the Little Dipper.
Hmm.
And at 4 in the morning, it's pretty much as high as it's going to get. It may get a little higher here, but this is the North Star. This is the bowl of the Little Dipper. And The only stars you'll probably see are the North Stars and the two at the bottom because the other ones are fairly faint. So the bowl of the Little Dipper is right here, and this faint star next to it is where the Ursid radiant is.
Okay.
So Ursid meteors will be shooting out of the bowl of the Little Dipper and heading in all directions. It can be seen all night long, but at that time it swings beneath the pole and it'll be lower in the sky.
Okay.
So from I would say 4 a.m. on to dawn is the best time to catch these meteors. Uh, these meteors will only produce probably 5 to 10 per hour. It's not that exciting compared to the Geminids, but you know what? 5 per 10 per hour is a lot better than your average night.
That's true.
So it's well worth it. Funny thing about the Ursids, they're associated with Comet Tuttle, and there have been outbursts of this shower. I've been in dark skies and I've seen 25 an hour from
Oh
this,
my.
which was really a surprise.
Okay.
This was back in the early 90s, and it turned out at that time, Comet Tuttle was at aphelion, which means it's the farthest from the sun.
Hmm.
So evidently, there's condensation of material opposite the comet that the Earth passes through.
That's really interesting.
Yeah, really crazy too. So when I told folks I saw 50 Earthids in one night, they say, "Okay, what kind of alcohol do you have keeping you warm that night?" No, no, but
That would have
it
the
turned.
opposite effect on you.
Yeah, for sure. Anyway, uh, this shower has been studied since about 1945 when it was actually discovered by radar. Same thing happened, a strong shower, and they were able to figure out the location. And it seems like I can't remember the exact period of Temple of Comet Tuttle, but when it's at aphelion, you can look for a lot more than usual.
Hmm.
Anyway, it's not at aphelion this year. We're not expecting anything more than 5 or 10, but still, I look south for almost all my showers, so it's very strange looking toward the north and seeing these meteors shoot upwards from the northern sky. So
True.
it's uh it's something new. Now, luckily, the IMO has charts for the constellation of Cepheus, so you can count stars here. Draco is another one, and nearby in Auriga. So this area of sky is well covered for your limiting magnitude. So um, give it a try. It's I know it's right before Christmas, uh, December 22nd, but that's the reason it's largely ignored. The weather
Ah,
is usually crummy too, this time of year, so it's more, it's overlooked.
yeah.
A lot of folks will have done their time for the Geminids. You say, you know what, I'm going to wait for the Quadranids, see a real shower again. Well, unfortunately, the Quadranids appeared during a full moon this year, so you
Ah,
you can't use that excuse.
no, there you go.
So unfortunately, we won't be talking about the Quadranids this year.
Okay.
Um, but normally that's a very fine shower. So anyway, I think I have one other thing I want to discuss, and that's
Okay.
for brand new people. I know we've talked about a lot of information, and if you are new it and you want to get interested, I would just go out and look. Don't even try to count. Familiar yourself with the area that the radiant is in, and then watch and notice how each shower member comes from that area of the sky,
Hmm.
but shoots outward from it. that's how you can tell a shower meteor from a random one.
Okay.
Now, if you're watching the Earths and you see a meteor shooting from Boötes toward the Ursan radiant, well, that's not an Ursan meteor. Uh, any Ursan meteor would shoot outward and head toward Boötes.
Okay.
So for beginners, get your feet wet by learning the constellations,
Hmm.
noticing that meteors will shoot outward from the radiant in all directions. And believe it or not, I take a dark shoestring and I hold it up to the sky if I'm not sure exactly what the meteor is. I see a lot of them off the edge of my field of view. So I'll grab that shoestring and I'll line it up to where I saw. And I says, you know what? That missed Gemini by 20 degrees. So there's no way it's a Geminid.
Okay. That's good,
So
good advice there. Another valuable tool in your toolbox, a
there
shoestring.
you go.
Now, meteor showers seem like they'd be a good opportunity for public outreach. So the only
That's
thing
very true.
negative would be the time of night it takes place.
The time of night and the stronger showers occur during the cold time of this
Hmm.
year in the northern hemisphere. So that's the downsize. We'd love to get groups of people, schools, astronomical, associations going
Yeah,
out and have a Gemini watch. That would be great. The only thing we need to remember then is we need individual counts. You can't pool your data into one. We
good.
had a lot of trouble with that before,
Oh,
and because everybody, we had one guy who had a group, and he had one recorder in the middle of the group, and it was just running the whole night. And
oh,
every time someone saw a meteor, they say magnitude 5 Geminid. Okay, that's great. I got a nice total of 6 people counting meteors, but scientifically worthwhile? No.
no,
It's the individual that really counts. Uh, the ALPO has had expeditions out to the Mojave Desert to
hmm,
watch showers, and we've had up to half a dozen folks out there, but we've run into some nasty weather,
mm,
some wind, and you know what? I think as we got old and crotchety, we just couldn't handle it. So we haven't done that in at least a decade now. So I think the last time I was out there, we had rain all three nights
oh,
in the Mojave Desert, believe it or not. So
yeah. Borrego Springs would be a nice spot for this too.
yeah, yeah,
'Cause that's a dark sky site.
yes, for sure. A lot closer too, but
Yeah.
we had people coming from as far north as Winnemucca, Nevada. So
Okay.
Robin would come down and drive from Winnemucca. We drive up from San Diego, and we had people from the Bay Area
Oh my.
shoot down to the Mojave Desert. So, but like I said, as we got older, it just got harder and harder to take.
Yeah. Well, maybe that's something we could do in the future.
Yes,
We,
for
we
sure, for
put something like
sure.
that together. That sounds exciting.
So we hope people will go out and at least give it a try. And even if it's not hourly counts, let me know what you saw and if you had a good time, and we can go on from there. And we have some Alpo people that always are out. Frank Melillo is one of them.
Hmm.
Greg Shanos is starting to supply me with observations, and Robert Hayes has been sending me data for the entire 36 years
Crazy.
that I have been, and they're all handwritten and mailed. So God bless him. He's been with me all these
Yeah,
years.
yeah, yeah. He doesn't own a computer.
Yeah. Amen.
Yeah, yeah. Very good. Well, Bob, I want to thank you once again for coming on the podcast. You're a regular visitor, and I really appreciate every
Man,
time
it's
you
a
come
lot of
on.
fun, and I enjoy telling folks about it, and I hope they have a good time. And take advantage of this because our next strong shower won't be until April.
Oh my. Okay.
So we'll have to look forward to the lyrics then.
There you go. All right. Well, thanks for coming on today.
Nice talking to you, Tim.
All right, that's going to wrap it up for this episode of the Observer's Notebook podcast. A big thank you again to Bob Lunsford coming on and telling us all about the Geminids Meteor Shower. If you enjoyed the podcast, please take a moment to give us a thumbs up and subscribe and share the podcast. It really helps listeners learn more about the Observer's Notebook. New episodes of the Observer's Notebook come out every few weeks. You can find us on iTunes as well as the ALPO YouTube channel. If you'd like to help support the podcast, you can do so through Patreon for for as little as a few dollars a month. Up to $35, you receive 1 year's membership to the Association of Lunar and Planetary Observers and producer credits on this podcast. The links to our Patreon page and the ALPO are in the show notes. I'd also like to extend a special thanks to our producers of this podcast, Steve Siedentop and Michael Moyer, for their generous support. As always, you can reach me directly at my email at tim.robertson@alpo-astronomy.org. Thanks for joining us today on this episode of the Observer's Notebook podcast. You can join the Association of Lunar and Planetary Observers today. It's just this easy. You can become a valuable member of this international lunar and planetary astronomy organization, founded in 1947 by Walter H. Haas. It's based upon the structure of the British Astronomical Association. You can join various lunar and planetary observing sections, contribute to our massive archive of observations. You'll have access to our extensive lunar and planetary gallery of over 20,000 photos and observations of the sun, the moon, comets, meteors, and the planets. You'll receive our quarterly publication, the Journal of the Association of Lunar and Planetary Observers. You'll have the ability to join the ALPO training program, which will teach you the finer points of making planetary observations. You can attend our annual virtual conference, and you'll have access to the Observer's Notebook podcast. Membership begins at only $22 a year. The way to find us, just go to your Google and type in ALPO Astronomy, and you'll see this prompt come up. There's our association with our website, alpo-astronomy.org, and you'll come to our homepage. If you look at the top of the homepage, it says Join ALPO. Click on that, and you'll come to the sign-up screen. Gives you the information on the organization, and there's two ways to join. You can join by mail, where you'll download a membership form, or you can pay online using PayPal. This is the PayPal processing page. You just fill out a few information lines, and then you're given the chance to click PayPal and join the association. Welcome to the ALPO.